Hello and welcome to the Journal. I'm Steve Kendall. The National Center for Water Quality Research at Heidelberg University in Tiffin has, among other activities, been monitoring Northwest Ohio's wetlands as part of H2 Ohio, but they do much more than that. And we're joined by the director, Dr. Laura Johnson, and research scientist Nate Manning from the center. Thank you both for being here. Obviously, water always at the top of mind here in Northwest Ohio along Lake Erie. Talk a little bit about the center, because you were on previously, but it's been a little while, so kind of explain to people overall what your center does and the range of activities you guys get into, because it's not just monitoring wetlands, it's a lot more than that.
Yeah, absolutely. Well, our center is a little over 50 years old, and we're actually best known for our long-term monitoring of streams and rivers, especially those that go into Lake Erie. And this fall, we'll be at our 50th year of monitoring on the Maumee and Sandusky rivers, which is quite a feat, I think. We are known for this monitoring of that, as well as the H2 Ohio wetlands, but we're also known for just our massive outreach and trying to get people to understand the factors that influence water quality and watersheds. A lot of that centers around agriculture and agricultural activities and how they influence water quality as well. We do an awful lot of education and have student researchers, that sort of thing. And we try to have some other opportunities for people to be involved in terms of we have the Sandusky River Watershed Coalition, where we do a lot of cleanup activities and outreach with students and classes and water camps and all kinds of stuff like that.
Yeah, and I noticed when I was looking through your material online, you do employ students from Heidelberg University. They're available to from all different disciplines, biology, chemistry, go across the sciences, that sort of thing. So it's an opportunity for them to really get hands-on and see all of this. When you look at what you guys are doing right now, and you mentioned the long-term monitoring, I believe in the material it says that you have the longest standing long-term monitoring record in the world, I guess, basically. Is that the case, that one of your projects has been going on, as you mentioned, for 50 some years, and that's the longest monitoring that's been going on in any aspect?
Yeah, it's, there's probably, you can dig into old records and find places that maybe have a little bit longer monitoring, but what you don't see is the consistency and frequency that we've been monitoring. So we monitor up to 3 times a day, all year round, and that's something that is really impossible to find anywhere else I would say globally. Yeah,
now when we talk about monitoring, and Nate, maybe you can jump in here, what sort of technology we're using? We talk about wetlands monitoring or Sandusky River, that sort of thing. So what sort of equipment are you using for that? It's obviously different places, different equipment, but what are some of the things people might see if they say, oh, here's one of our monitoring stations, here's what it is, here's how it works, here's what it does?
Yeah, so our river monitoring, if you've ever driven by a river and next to the road there's a little shack. A lot of those are the USGS gauging stations. Our equipment tends to be inside one of those buildings. We have a pump down in the river that pumps water up into that building, into a holding tank where we take samples from. They get stored in a automatic sampler in that building that we go and collect from once a week. And then that goes back to our main lab at Heidelberg, where we do all of the actual laboratory chemistry on the water.
All the analysis and everything.
Right. Yeah. And some of the stations now, though, we do have sensors that are in the building as well that is taking real-time measurements. We're trying to expand that. To as many stations as we can.
Yeah. Now, roughly, if you look at the monitoring, like on the Sandusky River or one of your locations, I mean, how many are we talking? How far apart are they? That kind of thing. I mean, how encompassing is this? We're saying, okay, we're monitoring this portion of the Sandusky River. Are we talking one every mile, one every 2 miles, 100 yards, or what's the normal setup for that? I know it probably varies, obviously.
It does, but for the large rivers, so for the Maumee and the Sandusky and the Cuyahoga and the Portage, we have a main monitoring station that's generally towards the end of the river, towards the mouth of the river, but not right at the mouth. And then we have, for especially the larger watersheds like the Maumee, we have sub-watersheds, so the Blanchard and the Tiffin, and so we can get a better picture of sort of what's happening up in the watershed.
Before it gets to the main river, right.
And then if there are areas of concern, we have the ability to go and do, point sampling as well.
Now, when you talk about some of the tributaries, you mentioned rivers. What about some of the larger creeks? I mean, Lucas County has Swan Creek, 10 Mile Creek, Blue Creek, those kind of things. Would you have monitors at some point in those as well? Because obviously they're feeding into the larger rivers and then into the main rivers like the Maumee and the Portage and things like that.
Yeah, we do for a lot of them. So we have 23 monitoring sites across Ohio and one in Michigan on the River Raisin. And so a lot of those are now the smaller creeks as well. And we have a paired watershed study looking at 2 of the smaller creeks in the Sandusky watershed and looking at, management practices in those watersheds and comparing these 2 smaller creeks and see how quickly we can pick up changes in them.
Now, and one of the things too, and sorry to interrupt you, when you're looking at these studies, and I know obviously you're not the only agency, the only institution, the only center working on this. Obviously you guys share all of this information because people are saying, look, we're doing all this monitoring, and I know that you guys are, grant-based, mostly donations, that sort of thing. But this is the kind of thing that people are getting a return for that investment on. These are the things that are going to make it, make the lake more functional, make the water safer to drink, all of that. So it is a large consortium of universities and agencies. I know NOAA's listed here. There's several of them that you all work together with. Do you when you do that, do you sort of all get together at some point, or is it all more now being everything virtual? You can kind of constantly be in touch, or you have to, let's get together 2 months from now and compare notes, that sort of thing?
So we work really closely with USGS because they have monitoring that's very similar to ours all around the same region, so throughout the Maumee. So we work together and put together a water monitoring summary that's hosted on the Ohio Lake Erie Commission website where we can have all of our information together. So we talk about that regularly. Our other folks that we work with, like NOAA, that's usually sort of throughout the loading season where we're building up to the bloom. And then we have a lot of university collaborators that are working on more short-term questions and grants. Usually that's just a lot of Zoom meetings.
Yeah. Well, we come back. You mentioned the loading season. Let's kind of break that down for people who hear some of those terms and they hear reference to, this is going on at this time of year. So maybe we can kind of explain a little more in detail what that means and what that window is and what you look for and hope you don't see or things you want to see changed as we go through those timelines. Back in just a moment with Dr. Laura Johnson and Nate Manning from the National Center for Water Quality Research at Heidelberg University. Back in a moment. Thank you for staying with us here on The Journal. Our guests are Laura Johnson and Nate Manning from the National Center for Water Quality Research at Heidelberg University. When we left that last segment, you talked about loading season, Dr. Johnson. Kind of define for the average person those sort of things and how you view this over the course of the year and what loading season is and what it means or may not mean in terms of water quality.
Well, the loading season got its start in the earlier 2000s. Tom Bridgman at the Lake Erie Center had noticed that when we had really wet springs, we tended to have a bloom in Lake Erie. And at some point, NOAA started to realize that they could quantify the severity of a bloom using satellite imagery. And then we had the data that could link how wet that year was and how much phosphorus came with how wet that year was. And so we started to put together a little forecast relationship between that springtime period and then started to add more months in, and finally got to the point where we realized whatever came in from the Maumee River between March and the end of July was very closely related to how big the bloom would get in August. So that was basically it, and we were trying to figure out what to call it. You can't call it spring loading because it goes all the way to July. So I like to call it the loading season because that seems to work really well. And it corresponds with other environments that get these big types of blooms or hypoxic zones. So there's a loading season for Chincoteague, or for the Chesapeake Bay. There's a loading season for the Gulf of Mexico, and they're all different depending on how that water is moving through that system and what it does once it's there.
Yeah, and I guess again, and going back to the fact that because you've been collecting data for so long, you actually, when that opportunity came along to say, hey, look, we've got numbers we can now apply to this and create some cause and effect, or at least make a little bit of a correlation and say, oh, look, when this happens, we're pretty sure this is what this is going to look like, and it's going to happen about this time if this happens at this time. Now, and the load that we're talking about, as you said, is phosphorus or this runoff. How much of it anymore is related to what used to be called point source? Have we gotten a better grip on that now when you guys monitor? Have you seen any change in the fact that maybe we're doing better with our point source the influx into these waterways?
Yeah, absolutely. The point sources we really tried to tackle in the early 60s and 70s when that first, like Lake Erie was dead sort of issues. And that was one of the first and easiest things to be able to ramp down. And the technologies have only since then improved in terms of reducing phosphorus coming through those point sources. Usually you think of a point source as wastewater treatment plant effluent, that's the majority of it, but it can come from industries as well.
Sure.
There is, Ohio EPA uses our data in combination with what they get reported to them through these point source inputs, and has been able to quantify basically what we call a mass balance. What % of phosphorus is coming from wastewater or from septic tanks, and find about no more than like 8% comes from these point sources, and the remainder is coming from what we call non-point sources, or basically I like to call it land runoff.
Yeah, and we've obviously over the course of time since we've been talking about this have gotten better at managing that and basically educating all of us on how to manage that sort of runoff, and farmers obviously a big part of that, and we'll talk about H2 Ohio shortly. When you look at the monitoring, Nate, and you see this sort of thing, anything that has, have you seen in your time anything that has radically changed? I mean, we're getting better at it? Are we seeing the monitoring systems are saying, hey, things we aren't seeing big extremes like really bad situations develop anymore?
Well, one of the nice things about sort of the temporal depth of our data is that we can go back in time and look for other periods in time that look similar to what we're seeing now, right? And see if there are patterns that repeat in the data. You know, long-term trends, 10 years, 20 years, 50-year trends. And I think what we're seeing is that, we are seeing effects of, things like the best management practices on the fields, but they're slow, right? They take time. And so we need to keep monitoring in the way that we've been doing, because it takes 5 years, 10 years, 15 years to see these actual changes, right? From one year to the next. Just because of how much it rained one year versus the other,
throws everything off.
You can have huge changes, and so you have to look at those long-term, trends.
Well, and I know, and you're absolutely right, because I know as we've talked about this over the last now 15 or 16 years, and before that, obviously, that everybody says, look, you don't. This problem wasn't created in a year. It's not going to be solved in a year. But if you can keep approaching it and finding out more and doing more of the right things and realizing, oh, this works better than that particular approach, you make progress that way. I know that one of the things you talked about, and you guys have initiatives beyond H2 Ohio, so talk a little about those, which whoever would like to jump in on that.
Yeah, well, we have a couple of new projects that we're working on. The one of them is the monitoring wetlands that were being constructed as a part of H2 Ohio, really as a way to see how effective and if they're filtering out as much of the phosphorus and nitrogen as we hope. The other one Nate had mentioned earlier is our pilot watershed study, and we're doing that in collaboration with colleagues at Ohio State, Jay Martin in particular. And for that particular project, we have a watershed that we've got a lot of information on what we think are the best practices, but all of those efforts are usually done at the edge of field, and we haven't seen practices being put in at scale. So we don't know the answer of like, how much of these practices do we really need? And it starts to answer that question of like, well, once we get as much practice in there as we think we need, how long is it going to take before we see that change? So the models tell us we need 70% of implementation of practices aimed to reduce phosphorus, particularly the dissolved phosphorus, which is really tricky to deal with. And if we get to that, then maybe we'll start to see changes, hopefully within a couple of crop rotations. But we don't really know the answer to that. Yeah, so we're hoping that this project will answer multiple questions for us, and it looks really promising. We've had some really great cooperation in that watershed, and I think we're going to hit those targets.
Oh, yeah, that would be great, because you say it is a step-by-step incremental process, and as you said, we learn. Well, you guys, you learn every day. You probably see things every day and go, oh, let's keep track of that. real quickly, when you talk about the differences in the phosphorus that we're talking, because I know recently, of course, there was the release of a report on here's what the summer forecast looks like for Lake Erie, and some of the people who don't necessarily think that things are moving quickly enough said, that's all well and good, and you mentioned, but they said the real problem, as you said, is focusing on dissolved phosphorus, and that seems to be something that kind of falls below the radar in this, at least in terms of some people's opinion on how we're addressing it. So what is the difference between dissolved phosphorus and the other runoffs that we're seeing that may include phosphorus?
Sure, yeah. So the dissolved phosphorus is phosphorus that is in the water that you can't see. So we filter out all the particulates, and then whatever is left over is dissolved. And I like to think of that as the sugar of the phosphorus world. It's really easy for algae to use. When there's a lot of it around, they can grow a lot. And then there's also phosphorus attached to little bits of sediment and mud in the water that get trapped and filtered out. But that stuff is more like, I don't know, like the brand cereal, I guess you could say, of the phosphorus world. It's a little bit harder to use, and only a little bit of it is actually available. So when we look at the changes in these two different forms of phosphorus, we see particulate phosphorus over time went down a little bit because there's a lot of efforts to reduce erosion in agriculture, especially through the 80s and 90s. But when the blooms returned, that's when we saw an increase in dissolved phosphorus. And that's why we focus so much on that, is because that has increased in around 2003 and it hasn't gone down yet. And we're trying really hard. So that's one of those things that we're like, we need more efforts in thinking about where we're putting our phosphorus fertilizer and how much we're putting on our land to be able to reduce that type of phosphorus.
Yeah, we come back because obviously H2 Ohio digs into that, and a lot of other programs too. But we can touch on that and the other initiatives you guys are working on as well. Back in just a moment with Dr. Laura Johnson and Nate Manning from the National Center for Water Quality Research at Heidelberg University. Thanks for staying with us here on The Journal. Our guests are Nat Manning and Laura Johnson from the National Center for Water Quality Research at Heidelberg University. We're talking about phosphorus, but obviously other chemicals are involved in what we put into the soil in a variety of ways for a variety of purposes. One of them is nitrogen. So Nate, talk about the role nitrogen plays in the things we're talking about with our watersheds in Lake Erie.
Sure. So nitrogen is sort of the other big nutrient of concern when it comes to water quality in this region. Phosphorus is really good with the harmful algal blooms, making the blooms grow, right, big, basically. And all of our models that predict how big the bloom gets use phosphorus. And they do a pretty good job, right, of estimating how big the bloom is going to get in the summer. But they don't do a very good job of estimating how toxic the bloom is going to be. Right?
Okay.
And there's a lot of research now that points to nitrogen as sort of a key to that toxicity, right? And so understanding how nitrogen, gets into our rivers, moves into the lake, and becomes available to these harmful algal blooms is really important in understanding, how they grow, but also how toxic they can be.
Yeah, because I know you see every once in a while, so there'll be a comment or something says, don't let your dog, don't let pets go into the water because it can be toxic to them especially. And and then you'd hear stories that sometimes a dog would go into a lake, and I know Grand Lake St. Mary's was very difficult 10, 12 years ago, that it was very toxic in places. So really the phosphorus creates the bloom, but the thing that really triggers a real danger level in terms of toxicity then is the nitrogen. And those are both chemicals that we apply for fertilizer and everything else. They're a major part of that. Is that also part of what we're trying to measure and say, look, you don't need as much nitrogen in the fertilizer you're putting on the soil, whether it's a yard or farmland, as opposed to phosphorus, or is that being dealt with the same way?
Yeah, and so there are ways. I've talked about best management practices. When to apply it, where to apply it, how you apply it to the fields, to your plants, can make a big difference in what we see, when we monitor in the river, right? And so making sure that those practices are put into place to conserve money for the farmers, right? Because it's cheaper, because you don't need as much.
The less you put on, the less you have to pay out.
Right, it's not just washing off, it's where it's supposed to be.
It's doing what it's supposed to do, right.
So I think, they're helpful on the land as well as in the lake
Yeah.
and in the rivers.
Yeah. Now, and we're hearing, of course, a ton about H2 Ohio. Obviously, that involves everybody in the entire spectrum in this, whether it's from the agricultural community, the scientific community, the tourism community, all of those people that rely on the lake for some purpose, or the people that just drink the water from the lake. H2 Ohio, talk a little about your involvement in that, because obviously you've got a monitoring program for wetlands. What do you expect to find out from that? Obviously, you're going to see, are we having a positive impact? Are the wetlands doing what they're supposed to doing? Are we damaging them, and what's the status of that from your perspective?
Yeah, so we are a part of a wetland monitoring team. It's housed under the Lake Erie Area Research Network, or LEARN, and there are 6 different institutions involved with monitoring wetlands that are being constructed through H2 Ohio. Now, DNR has constructed, I think we have up to 170 or more wetlands projects that are funded at least, or in progress. Not all of them are completely finished yet, but we've been monitoring them with this team for about 4 years now, and we're finding that across the board, they're pretty good at removing phosphorus. That's sometimes a question. Well, wetlands are kind of well known for being able to remove nitrogen, no questions asked, but sometimes phosphorus gets sticky and it'll accumulate in places, and so we need to keep a track of that to make sure the wetlands are actually doing as much as we want them to be doing to improve our waterways. And concert, when we think of that with agriculture and what Ohio Department of Ag is doing with their H2 Ohio program, I like to think of them as sort of targeting the same issue just in slightly different ways, where an ag field might be trying to reduce the amount of phosphorus in runoff. If we take that same ag field, if it was turned into a wetland, then you wouldn't have some of that runoff because it wouldn't be in production, wouldn't be getting fertilizer. But then, and oftentimes we actually see it holding more phosphorus even, and then you get these sort of even bigger gains. So I like to think of every acre of wetland we're putting out there, so far from what we've measured, seems to be doing above and beyond in terms of removing phosphorus before it gets to downstream ecosystems. The real question we have is if we're going to have enough out there to make a big difference.
To significantly change the
But when you put all of these H2 Ohio programs together, then that's where I think that we'll see that, stacking all these different types of practices together, they all play a role and can work together to improve water quality.
Yeah, and that's what we've talked about over the years, that it isn't just one solution, it isn't just one particular way of dealing with it. As you said, it's all of those in conjunction working together, and then being able, especially with all of the data, then to be able to look and say, oh, this is working if we do these certain things at this level. When you look at what, because I know there's a chart that I know you sent over that shows the objective, our target for the watershed and the lake and that sort of thing, and sometimes over the course of the 20-year period or whatever is listed there, we've hit the objective, but in a lot of years we haven't. Is the feeling that we're going to make progress on this, and as we apply more of this, that we'll start to see us getting that down to the level where we're comfortable with what's going in and what's happening once it gets to Lake Erie and the watersheds along the way?
Well, I like to remain optimistic. We had a pretty wet period for the past 10 years, and we've sort of gone into a more normal average in terms of runoff for the Maumee River in the past, say, 5 years, I would say. So I remain optimistic because I haven't seen as much initiative in terms of trying to get the right practices on the ground as I've seen through H2 Ohio. So I think what we have to remember is that that program is only a few years old, and I would expect it to take a few crop rotations before we start to see the changes in how we're dealing with these nutrient applications to actually have an effect. So we're at something like 35–40% of the watershed has these new nutrient management plans in place and this practice implementation. We just have to have a little bit of patience to be able to see if we're actually starting to see those reductions. Right now, we're not seeing a lot of change. We're seeing that what we're getting in terms of what's coming out of the Maumee is tracking right with how much water or flow we're getting. So that's why we can see like our bloom size when we look at our forecast is still very much related to how much rain or precipitation we're getting in a given spring.
Now, one thing real quick, and I know we're in the last couple of minutes here, there is a big effort, of course, now to clean ditches, clean creeks, to basically streamline them. Is that, on one hand, that's better water flow, but is that necessarily from, I know it's not a simple question, Is it better that streams are completely clear and water just flows through them unimpeded, or would it be better if maybe there is some stuff, some logs, some blockage, a little bit of slowing the process, or does that create, it holds the problem there and creates another problem? I know that's a question for a different whole show probably, because I know there's an effort to clean everything, to streamline everything and move water as fast as we can to the lake. Would that be seen long-term as another problem we'd have to look at to see what that means in terms of what's going to happen once it gets there?
Well, with that you have, this, especially the phosphorus that's tied to those sediment particles, right, doesn't have a chance to settle, right? And so it's being transported further
downstream, faster.
When you have plants, when you have some, sinuosity in the creeks, right, it gives that stuff a chance to settle. It allows the plants to absorb,
as opposed to it going to the lake and being absorbed and bloomed and everything.
And the algae, eating it up.
Because there are big projects underway in Lucas County, I know, to clean a ditch or a creek that hasn't been cleaned in 100 years, and it's going to change that considerably. So, and a lot of people see it as a big benefit, but from you guys' perspective, you might say, well, there's another variable we get to deal with now. 100 years of being this way, now suddenly over the next 6 years it's going to change radically. Well, I appreciate you guys coming on and talking about this, and as things progress and as you have more things coming in, more details, we'll be glad to have you back on to talk about the progress we're making. As you said, we're optimistic, we're addressing the issue, we're trying to find what works and then really apply that as opposed to things we've tried in the past that maybe weren't as effective. So we appreciate the work you guys do, and hopefully we'll never have to worry about not being able to drink the water in Lake Erie as there was maybe 10 years ago. So we appreciate the efforts you guys make. So thank you again.
Thank you.
Yeah. You can check us out at WBGU.org. You can also watch us every Thursday night at 8 o'clock on WBGU-PBS. We will see you again next time. Good night and good luck.